And welcome, guys. I'm going to be talking about stoichiometry today. Now, stoichiometry is really just a recipe chemistry uses to involve math. You start with a weight, let's say in grams, and it tells you how much product you'll make in grams, moles, or atoms. Now, this whole thing will only work if the chemical equation is balanced. Check out my previous video on balancing equations. Now, to the question. Now, let's say you're given 11 grams of hydrogen gas and want to know how much water you can make when it reacts with oxygen. Here we have our chemical equation, our unbalanced chemical equation. The first thing you do is you look at this. It's not balanced, so you want to balance that out. Highlighted where we changed it, the 2 in front of the hydrogen gas and the 2 in front of the oxygen or the water. Now, step 1 is to convert grams to moles using molar mass found on the periodic table. Now, for those of you who don't know, molar mass is this number right here, 1.008. It's in grams per mole, so that means 1.008 grams of hydrogen are in 1 mole. Now, since it's hydrogen gas, it always comes in H2. So we have H2. We need 1.008 times 2. That gives us 2.016 grams of H2 per mole. So now we multiply it by our original, which is 11 grams. We want to go to moles, so we put that on top, grams on the bottom. The way I remember this is out with the old, in with the new. So we have out with the old, grams on bottom, it's out, get it out of here. And moles on top, new. This is the better one. It's always on top. Now what this does is cancels out grams and leaves us with moles, hydrogen gas. Now a different way you could put this in your calculator is 11 over 2.016 or 11 divided by 2.016. But really, I like to keep it in this format to keep it the easiest to read, least confusing. Now, next thing we do, now that we're in moles hydrogen gas, is there's something called a ratio. Now, this ratio is the stoichiometric coefficients, which are these numbers that we added before our compounds and elements. Now, we're going from hydrogen gas to water because we want to know how much water you can make with hydrogen gas. Now, this ratio seems to be a 2 to 2 ratio. See it right there. So you take that ratio and you multiply it by your original or by your equation of what you have now. It's going to look like this. Now remember, out with the old, in with the new. Hydrogen gas on bottom, water on top. We want to get to water. We don't want hydrogen gas anymore. So that's on the bottom, water's on top. Now, another way you can think about this ratio with the stoichiometric coefficients with this equation in front of us is 1 mole of oxygen gas makes 2 moles of hydrogen gas. So that has a 1 to 2 ratio. Or you could flip it around and say a 2 to 1. 2 waters make 1 oxygen. Now, after the ratio, we're in moles of water. Let's just say we want to get back to grams. We want to know how many grams of water. Now, we do this by going back to the periodic table and pulling out that molar mass. So since we still have 2 hydrogen atoms right here, we want to multiply 1.008 by 2 and add that with 15.999. Now the reason why we're adding is because it's in a compound and think of it as one thing. So it's this thing equals both of these numbers. All right, so we got that typed out. Comes out to 18.015 grams of water. Now we take that number and we put it in dimensional analysis again. Now what that will come out to be is 18.015 grams of water over 1 mole of water. So remember, out with the old, in with the new. Old on bottom, we don't want moles, we want grams. So just cancel out moles. And now I like to keep it in this format all the way through, type it all on my calculator at once, So at this point, I would be typing it into my calculator, and usually the answer comes out. Your chemistry teacher always wants two significant figures and scientific notation. So the answer comes out to 9.8 times 10 to the 1 grams of water. So now that we got that, we can try something a little bit harder. So Mr. Avogadro, now he came up with a constant 6.022 times 10 to the 23rd. This shows how many atoms there are in 1 mole of anything. So this constant works the same way as anything else in dimensional analysis, just we got to multiply it. So this question is going to fly by a little bit quicker since we already have the basics down. So the question is, how many atoms of oxygen do we have if we mix it with 5 grams of propane? First, obviously, our unbalanced chemical equation, propane right here, oxygen gas, carbon dioxide, and water. Now, first things first, want to balance it. We've got our balances there, 5 moles of oxygen gas, 3 moles of carbon dioxide, and 4 moles of water. Now, go back to that periodic table and molar mass. Obviously, there's 3 carbon, so we multiply the molar mass of carbon, which is 12.011 grams times 3, and then we add it with the 8 hydrogen, which is 1.008 grams times 8, and that gives us 44.11 grams of propane. Now we multiply it by original thing, which is 5 grams of propane. So now that we're in there, cancel out the grams, out in, out with the old, in with the new. We're in moles now. So next thing's up, multiply by the ratio, 5 moles of oxygen to 1 mole of propane. So our ratio is a 1 to 5. We're going to oxygen, so we put the oxygen on top, which is the 5 on top, and the 1 propane on the bottom. So that gets rid of the propane. And now that we're in moles, oxygen. So now that we're in moles, this is where Avogadro's number comes in play. You can only go to atoms and molecules from moles. Moles is kind of like the bridge to, you can get anywhere with it. Now, what we do is we set up the same way. We multiply it by 6.022 times 10 to the 23rd atoms over 1 mole oxygen. So we're going to atoms, so the moles cancel out. Obviously, we go in it, so it goes on top. Now, a little trick I like to do on my calculator is I like to put these in parentheses. I like to put it in parentheses around Avogadro's number because it seems to get confused sometimes, especially the one I have. Now I have the TI 30XS. I highly recommend this one, for chemistry at least. So now we put all of that in to our calculator, set it up, 2 significant figures, scientific notation. It comes out to 3.4 times 10 to the 23rd atoms of oxygen gas. Now, a very important thing, never forget to label what you're in. This right here, we're in atoms. You see I labeled it all the way through because if you're doing it, setting up this way, you'll get confused on which step you're actually at. So, maybe here you think you might be in grams or you think you might be in atoms, or like it's happened to me. Just make sure you always label it, especially on tests, guys. Now, leave any video ideas in the comments. Thank you for watching. This was Stoichiometry.